Hey everybody. Today we're doing an example problem using the first derivative test. We're going to look at the function x squared over 1 minus x squared. We'd like to determine any local maxima and minima of this function, and we'd also like to find where this function is increasing and where it's decreasing. These are all first derivative questions, and to answer them, we're going to want to keep in mind four closely related facts. If the derivative is positive on an interval, then the function is increasing there. If the derivative is negative, then the function is decreasing on that same interval. If the derivative changes from negative to positive at some critical value, then the function has a local minimum at that critical value. And if the derivative changes from positive to negative at a critical value, then the function has a local maximum at that critical value. So in order to solve this example problem, we're going to get a first derivative, build a sign chart, and determine where f prime is positive, where it's negative, and where it changes sign. So let's get right down to it. We differentiate this using the quotient rule. Low d high minus high d low, draw the line and square below. In this case, it's very helpful to simplify. We're going to need to plug in different values into this derivative, and so it'll be a lot easier if we don't have to deal with quite so much of an algebraic mess. In this case, we get 2x over the quantity 1 minus x squared squared. The derivative is 0 when x is 0. That's going to be a critical value. And the derivative does not exist when x is plus or minus 1. Those are the three values where f prime can change sign. Notice, by the way, that negative 1 and 1 are not actually critical values. Although f prime does not exist at 1 or negative 1, the original function f of x isn't defined at those values. In order for an x value to be a critical value, the function itself has to be defined at that value. Our next step is going to be to construct a sign chart for f prime using these three cut points, negative 1, 0, 1. Again, let me stress, even though negative 1 and 1 are not critical values for the function f of x, they are cut points on the for f prime of x when we're determining where it can change from positive to negative or negative to positive. So here's our sign chart. It's just a number line with these cut points labeled negative 1, 0, and 1. We're going to test a value in each of these four intervals, negative infinity, comma, negative 1, negative 1, comma, 0, and so on. For the first interval, negative infinity, comma, negative 1, I'll test the point negative 2. I plug that into f prime, I get a negative value back. F prime, therefore, is negative on that entire interval, because we know it can't change sign except at these cut points. From negative 1 to 0, I'll choose the point x equals negative 1/2, and the derivative is negative there for our negative 1/2, and therefore negative on that whole interval. Between 0 and 1, I pick x equals 1/2, and I find that the derivative is positive. And between 1 and infinity, I pick the value 2, and I find the derivative is positive again. Now that we have a complete sign chart, we can draw some conclusions about f of x using what we know about f prime. The function is going to be decreasing wherever the derivative is negative, and that is going to be the case from negative infinity to negative 1 and negative 1 comma z and negative 1 to 0. Of course, the function isn't defined at x equals negative 1. Similarly, the function is going to be increasing whenever the derivative is positive, and that's the case from 0 to 1 and 1 to infinity. Again, the function's not defined at x equals 1, so we want to make sure to leave that out of our solution set for this part of the problem. We only have one critical value, x equals 0, and we see that the derivative changes from negative to positive there. So the function changes from decreasing to increasing and therefore has a local minimum. At x equals 0, by the way, f of x is 0. So the local minimum is going to be the point 0, comma 0. Here's the graph of the function that we've been looking at, x squared over 1 minus x squared. It has all the characteristics that we determined on the previous slide. It's decreasing from negative infinity to negative 1 and from negative 1 to 0. It's increasing from 0 to 1 and 1 to infinity, and it has that local minimum at the point 0, comma 0.